Hello guys, today's video is about the implementation of array-based queue, and this is a data structure in the course of Java data structure and algorithm. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Queue basics. Linear data structure. FIFO data structure. It works as first in, first out, just like a real life queue. We insert on one end and remove from the other end. Normally we delete from the front and insert at the end of the queue. Usage. Queue is used in various applications. It used to manage data flows and tasks in applications. Used in event simulations like bank queue, ticket queue. It is used in graph data structures for various purposes. Array-based queue complexity. Insertion is ON, as we are inserting at the end of the array. So it takes only single instruction to insert a new element at the end of the array. Deletion is ON in the best case, single element in the queue, because we do not need to shift the elements. Otherwise it is ON because we have to shift the elements towards the left side to fill the hole we make while deleting the first element in the array. Peek is ON because we are checking the first element in the array. Search is also ON in the best case when the element exists at the beginning of the queue, and ON in case of worst and average cases because we have to find the element using linear search. Fixed memory container, because at the backend we are using array, can be written with dynamic memory by increasing the size of the array. Thank you guys. Let's begin coding. Hello guys, I have created NetBeans project for the implementation of array queue. So I added a class named queue and wrote skeleton methods that will support the functionality of the array-based queue. So we have a maximum capacity of the array variable to store the data, and the count variable to count the number of elements currently stored in the queue. Constructors that will allocate the memory, and queue method that will push a new element at the end of the queue. Dequeue method to remove the front element from the queue. Peek method to view the front value of the queue. Int size, this method will return the number of elements within the queue. And is full, this method will check if the queue is full or not. Because this is a fixed memory array-based queue, so we have to check if it is full or not at the time of enqueue. And is empty method, this method will check if the queue is empty or not. Print method that will print the queue to the standard console. I have written the tester for the array-based queue, created queue object, a random generator object that is imported from the java.util.random, and iterated 5 times in a for loop, generated a random number and printed the number, then added the number by using enqueue method of the queue class, and print the state of the operation enqueue, whether it is correctly added or not, and then print the size of the queue, and then print the actual queue. And this will happen at every iteration of the for loop, and it runs for 5 times. Similarly, I will remove 5 items by, first of all, I will check what is stored at the front of the queue by using a peek method and display the number, then dequeue the number and print it, and then check the size of the queue, and afterwards print the state of the queue. This is a very simple tester for the testing of functionality of the Q class. Let's begin coding for the Q class. I wrote all these things to save time, to save video time. Let's start the coding. So Q constructor, we are going to allocate array memory. Q is equal to new and max size, and we initialize count to 0 because the list is empty at the creation time. Okay, enqueue method. So first of all, we check full or not. If this dot is full, so we return false. Otherwise, we will store the value at the end of the queue. This dot queue and count plus plus, increase the count after storing the new value. Return true. Operation is successful. Now the dequeue method. First of all, we check if is empty. If it is empty, return false, do nothing. Otherwise, shift all the elements one position left. So for int I0, I is less than count minus 1, we will iterate 1 less than the total number of elements in the queue, and we shift them towards left. So this dot queue I is equal to this dot queue I plus 1, and reduce the size. Count minus minus, return true. Return true to indicate the deletion or dequeue function works perfectly. And this is peek method, and peek method will return first element in the queue, and size method simply return the count of the number of elements within the queue. So is full method check if the queue is full. So we return count is equal to max size. This is maximum capacity of the array based queue. And is empty method to check if the queue is empty. So we return count is equal to 0. 0 means no element is there. So here we will print the queue. If this dot queue is empty and not empty, so then we will do s out. Let's use the formatted output %d and this. Okay, otherwise for int I is equal to 1, I is less than count I plus plus, s out %d and q I, and that's it. And at the end we can print new line. New line is already there, and let's make it print on the same line. Okay guys, these are the functions implemented. This is the very simple data structure, and it works from the both ends. We enqueue element at the end of the queue, and we exit or remove the element from the front. So let's test it. So let's run it. Okay, so now let's check it. So first of all, we generated first random number 37, and it is enqueued to the queue. So its size becomes 1, and the element is stored here. Then we created and generated new number, that is 77. So after adding, size 1 becomes 2, and these are 2 elements currently in the queue. So see, 77 is inserted or added at the end of the queue, and 37 remains at the front. Then 51 comes at the end of the queue, and next number is 94 comes here at the end of the queue, and then generated 1, and 1 comes at the end of the queue, and the number of elements are 5. Now next we will remove the element from the front of the queue. So front element is 37 is removed, and size reduced to 4, and 4 elements are here. 37 is removed. Next 77 is removed, and the size is reduced. Then 51 is reduced. Then 94 is removed, and size is reduced to 1. Then the last element is 1, it is removed, and the queue is empty now. Size is 0, and it is working perfectly. Thank you guys. This is all about implementation of array-based queue. If you have not already subscribed to my channel, please subscribe and encourage the content. Thank you very much. See you in the next video.